A stationary ball is hanging from a light string. A pellet from an air rifle is traveling horizontally and becomes embedded in the ball. The velocity of the pellet when it strikes the ball is 160 meters per second. So A asks to calculate the speed of the ball and the pellet immediately after the impact. So here we can use conservation of momentum, where the initial momentum must be equal to the final momentum. The initial momentum here would be, remember that to convert all of these into kilograms. So it would be the mass of the pellet, which is 2 times 10 to the minus 3 kilograms, times 160. So this is mv, will equal to, so the mass of the ball and the pellet would be 252 grams, so 252 times 10 to the minus 3 times v. So now v would be equal to this expression. We're going to be getting a value of 1.27 meters per second. Now B suggests why combined kinetic energy of the ball and the pellet after the impact is less than the initial kinetic energy of the pellet. So there are two things to talk about. One is that because this is not inelastic, so just so you know, inelastic collisions, such as this one where they stick together, inelastic collisions, it is impossible, so energy must be lost as heat. And we can also see that since kinetic energy is equal to half mv squared, even though the mass significantly went up by a factor of 126, 6 times, that means the velocity also went down by a factor of 126, but because here in kinetic energy it's velocity squared, the fact that it goes down by 126 would be squared, so it would have a much greater impact, therefore kinetic energy would be lost. The ball with the embedded pellet rises to a maximum vertical height h. Draw and label the free body diagram for the ball at height h. So currently there are two forces acting on the ball. Of course there will be mg, which is the weight in this instance. This will be acting downwards. And then you have the tension, which is in the same direction as the string, and this will be the tension. And it doesn't have to be too precise, but try to make sure that like the vertical is roughly similar to the weight. But then again, the mark scheme doesn't require you to be too specific. So D is determine h. So in this case, because it reaches the maximum vertical height h, that means the kinetic energy will all become gravitational potential energy. So that means that half mv squared is equal to mgh. H is what we're looking for, and in this specific instance the masses will cancel out, so v squared is equal to 2gh, v is equal to root 2gh, and we know from part A that the velocity is equal to 1.27, so 1.27 is equal to the square root of 2 times 9.81 times h. And then you can use your calculator, whatever you would like to solve, but h in this case would now be equal to 0.08 meters, and it's written in the mark scheme as well as, or as 0.082 as 8.2 times 10 to the minus 2 meters.